Now that we have explored what we will be learning, it's time to talk about something just as important: how you will be judged. Welcome back, and today we will dive into assessment objective behind the O level physics 5054 examination. The secret blueprint behind every exam question. These objectives tell you exactly what examiners are looking for and how your marks are earned. Whether it's about recalling facts, solving problems, or designing an experiment. Mastering these objectives is the key to unlock top grades in physics 5054. So in this video, we are going to break down AO1, AO2, and AO3. What they mean, what skills they test, and how to tackle each one with confidence. Let's start with the first and arguably the most important one, AO1, knowledge with understanding. AO1 is the knowledge with understanding, and trust me, this is the core of your physics exam. If AO1 was a person, it would be that friend who always knows the fact, the formulas, and the specific theory. It's about what you know and how well you understand it. Now, here's the deal: AO1 makes up a massive 50% of your entire grade. That's half of your marks. So, you cannot afford to skip this one. So, what exactly AO1 looks for? It's your ability to recall scientific facts like what is Newton's second law or what is the unit for resistance. It checks whether you know your scientific vocabulary, terms like conduction, radiation, isotope, diffraction, reflection, and more. It wants to see you use correct unit and symbols. For example, using meter per second for acceleration or ohms for resistance. And it checks your understanding of lab equipment and safety, like how to use a voltmeter or why you wear a goggle in a practical. Let's try a quick example. Define density. Your answer should be density is the mass divided by volume. Short, sharp, and accurate. That's AO1 in action. Another one, state one use of gamma radiation. AO1 expects you to say something like sterilizing medical equipment, and that's it. No need for explanation unless the question asks. So, some tips for planning for AO1 could be: don't just read your textbook, test yourself constantly, use flashcard, quiz app, and past paper. Get those facts logged in. Also, learn your formula and unit like they are your favorite songs. You should be able to recite them in your sleep. Examiners says about the weakness that a lot of students lose marks simply because they forget to write unit or use vague terms. So instead of writing it gets faster, say the velocity increases at constant rate. AO1 is all about showing the examiner that you know the language of physics. If you get this part right, you're already halfway there. Next, we have AO2, handling information and solving problem, which is all about applying what you know. You see, AO1 is like learning the rules for football, but AO2 is actually playing the game. It's worth 30% of your total grade, and it checks if you can take those physics concept and use them in different situations. This is where the real thinking starts. AO2 wants to see you analyze information from graph, tables, and diagrams, solve calculation based on physical laws, make prediction based on scientific reasoning, interpret result and explain what's going on. For example, a graph shows how temperature changes over time. What is the rate of temperature increase during the first 5 minutes? Here, you need to calculate the gradient, use correct unit, and interpret the slope. That's pure AO2. Another one. A car of mass 800 kg accelerates at 2 meters per second. Calculate the force acting on it. AO2 expects you to recall the formula F is equals to ma, plug in the value, and show you working. F is equals to 882, that is going to give 1600 Newton. What's important here is not just getting the right answer, it's how you show it. Examiner looks for clear steps, proper layout, and a final boxed answer with unit. Tips for AO2 include practice interpreting unfamiliar scenarios. Don't just memorize, apply your knowledge. For example, don't just know what refraction is, know how to explain it when light enters water at an angle. Try a question that begins with words like calculate, explain why, predict what happens if, use the data to interpret. Also learn to convert unit and rearrange formula. These skills comes up a lot. Examiners often say students can do math but forget what it means. For instance, if your answer is speed is equals to 20 and you don't say 20 meters per second, you can lose your marks. Or if you calculate energy but don't state whether it's kinetic or potential, that matters. So AO2 is all about thinking on your feet. If AO1 is your knowledge toolbox, AO2 is how to use the tool to solve real physical problems. Finally, AO3, experimental skills and investigation. This final assessment objective, AO3, focuses on your experimental skills. This is worth 20% of your total grade, and it tests either through a real lab practical, paper 3, or a written version of it, which is paper 4, ATP alternative practical. In simple terms, AO3 wants to know, can you think and work like a scientist in a lab? Here's what AO3 is all about: planning experiment, taking accurate measurements, recording data clearly, drawing and interpreting graph, evaluating methods and identifying errors. For example, an example task of AO3 is you are given a metal rod, a clamp, and a ruler. Design an experiment to find how its length changes with temperature. AO3 expects you to describe a setup, state how you would use reading, mention variables to control, suggest safety precautions, and maybe even what errors to expect, like expansion being too small to measure easily. Another common AO3 task is you are given a temperature time graph from a cooling experiment and asked to describe the trends. You may also need to draw a line of best fit or calculate a rate of change. Some tips for AO3 is to know your basic lab setups like measuring resistance, finding density, or verifying Ohm's law. Always write answers in clear steps. Think like you are explaining it to a friend. Practice reading scales on instruments like ammeter, thermometer, and rulers. These often appear in paper 4. Also learn common sources of error like parallax error, reaction time delay, heat loss to the surrounding. Be ready to suggest how to improve experiments using digital timers, insulating material, or repeating readings for accuracy. One common comment from examiner that students often describe that they see but forget to explain why it happened, or they just give vague errors like human error. Instead, state difficulty in reading thermometer due to small scale division. AO3 is about showing your understanding of practical side of physics. Whether you are in a lab or not, your ability to think critically and scientifically is what examiner wants to see. So now you know what the examiners are looking for: AO1 for what you know, AO2 for how you apply it, and AO3 for how you think and work. But there's a twist. Even if you understand the content and the objective, you can still lose marks if you misread the question. And that's where command words come in. Words like define, explain, compare, or calculate aren't just suggestions, they are instructions. In the next video, we will decode these command words so you will know exactly what each question wants from you and how to respond for full marks. See you there.